Today we'll start with the second chapter, Pythagoras Theorem. 7 marks. Weightage in the board examination is 7 marks. From 7th standard, we have been learning Pythagoras Theorem. What is Pythagoras Theorem? In a right angle triangle, square of the hypotenuse is equal to the sum of squares of remaining two sides. Suppose this is triangle ABC, where angle B is 90 degree. Then side opposite to right angle is called hypotenuse. So in this triangle ABC, AC is the hypotenuse. AC square, that is hypotenuse square, is equal to the sum of squares of remaining two sides. Therefore AC square is equal to AB square plus BC square. So we have studied how to use Pythagoras theorem in right angle triangle, rectangle, square and rhombus. So let us solve some examples based on this. In triangle PQR, angle Q is 90 degree, PQ is given 5, PR is given 13, you asked to find QR. So triangle is a right angle triangle, right angle at point Q, angle Q is a right angle, PR is the hypotenuse, PQ is given 5, PR is given 13, QR you have to find out. Since triangle is right angle triangle, we'll use Pythagoras theorem to find QR. So solution, in triangle PQR, it is given that angle Q is 90 degree. What is the reason? This is given. So what I will get? PR square is equal to PQ square plus QR square. What is the reason for this is Pythagoras theorem. Substituting the value PR, how much is PR? 13 square is equal to PQ is 5 square, QR square I have to find out. 13 square is 169, that is equal to 25 plus QR square. So I have to find out QR square. So I will keep QR square on the right hand side. This plus 25 I will transfer to left hand side. So it will become 169 minus 25 is equal to QR square. This is 144 is equal to QR square. So taking square root on both sides, what I will get? QR is equal to 12 units. If units are not given, you have to just write units. So in this way, in right angle triangle, if length of two sides are given, using Pythagoras theorem, we can find out the third unknown side. Example 2. Length and breadth of the rectangle are 24 cm, 7 cm respectively. Find the length of its diagonal. Here, I will assume that quadrilateral ABCD be a rectangle. Let quadrilateral ABCD be a rectangle such that AB is equal to 24 cm, BC is equal to 7 cm. I have to find out length of its diagonal. What is diagonal? If I join, AC is the diagonal. This I have to find out. Or BD is the diagonal. Once I get AC, BD will be same, as we know that diagonals of rectangle are congruent. Now, since quadrilateral is a rectangle, all its angles are right angles. So, in triangle ABC, angle B is equal to 90 degree. Reason for this is angle of a rectangle. Now, I will apply Pythagoras theorem. AC square is equal to AB square plus BC square. Reason for this is Pythagoras theorem. Substituting the value 24 square plus 7 square. I know that 24 square is 576 plus 49, that is 625. So AC square is equal to 625 will give me AC is equal to 25 centimeter. So what is the final answer? Length of the diagonal is equal to 25 centimeter. So in this way, using Pythagoras theorem, I can find out diagonal of a rectangle if length and breadth are given. Question number 3. Find the length of the diagonal of a square with side 12 centimeter. So we have given a square whose side is 12 centimeter and you are asked to find what is the length of its diagonal. Suppose quadrilateral PQRS is a square. So we know that all angles of a square are right angles. So if I consider this triangle PQR, in triangle PQR, angle Q is 90 degree. PR square is equal to PQ square plus QR square. That is, hypotenuse square is equal to sum of squares of remaining two sides. Reason is Pythagoras theorem. Since this is a square, all sides are 12. So PQ is 12 as well as QR is also 12. 12 square is 144. 12 square is 144. PR square is equal to 288. Taking square root, PR is equal to square root of 288. So that is equal to 288. I can write it as 2 into 144. So square root of 144 is 12. So PR is equal to 12 root 2 centimeter. The final answer, the length of the diagonal of a square is 12 root 2 centimeter. So in this way, if side of the square and diagonal, out of these two, length of one, either side or diagonal is given, you can find out remaining part. Question number 4. Quadrilateral ABCD is a rhombus. AB is 10 centimeter, AC is 16 centimeter. Find BD. This is the quadrilateral ABCD whose all sides are congruent because quadrilateral is rhombus. So what is the property of rhombus regarding diagonals? The diagonals of a rhombus are perpendicular bisectors of each other. So you get AM is equal to half of AC. Half of AC is given as 16. Half of 16 is 8 centimeter. BM is half of BD, but BD we have to find out. And angle AMB is 90 degree. Why? Because diagonals are perpendicular bisectors of each other. Now in this triangle AMB, which is right angle triangle, we'll use Pythagoras theorem. AB square is equal to AM square plus BM square. Reason Pythagoras theorem. AB value is 10, 10 square. AM value we get from statement 1 as 8 plus BM square. 10 square is 100 is equal to 8 square 64 plus BM square. So this plus 64 will come to this side and now I will get BM square is equal to 100 minus 64 is equal to 36. Taking square root, BM is equal to 6 centimeter, but I have to find out length of another diagonal which is BD. BD is 2 into BM, that is 2 into 6, that is equal to 12 centimeter. So the length of other diagonal of quadrilateral ABCD which is rhombus is 12 centimeter. Now we'll study a new concept, Pythagorean triplet. What is Pythagorean triplet? If in a triplet of natural numbers, if the square of largest number is equal to the sum of squares of remaining two numbers, then the triplet is called Pythagorean triplet. It is a group of three natural numbers where the square of largest number is equal to sum of squares of remaining two numbers. That is, see, 3, 4, 5. This is a group that is triplet. Triplet means group of three numbers. The largest one is 5. 5 square is 25. Remaining two are 3 and 4. 3 square plus 4 square. 3 square is 9. 4 square is 16. Addition is 25. What did I get? 5 square is 25. And 3 square plus 4 square is also 25. So 5 square is equal to 3 square plus 4 square. Reason from statement 1 and 2. And therefore 3, 4, 5 is a Pythagorean triplet. Let us consider the second example. 11, 61, 60. This order of number may vary. 61, the largest ones. 11, 61, 60. Out of these three numbers, 61 is the largest number. Square of the 61 is 3721. Remaining two numbers are 11 and 16. 11 square plus 60 square, that is 121 plus 3600. Addition is 3721. Again, 61 square is 3721 and sum of squares of remaining two numbers is again 3721. Therefore, 61 square is equal to 11 square plus 60 square. Statement 1 and 2, and therefore 11, 61 and 60 is the Pythagorean triplet. One more example we will solve. Suppose consider 7, 8, 9. This triplet is Pythagorean triplet or not, that you have to justify. The largest number is 9. 9 square is 81. Remaining two numbers 7 and 8. 7 square plus 8 square, that is 49 plus 64. 49 plus 64 is 113. Here 9 square is 81 and sum of remaining two numbers is 113, which are not equal. Therefore 9 square is not equal to 7 square plus 8 square. This is from statement 1 and 2. And therefore 7, 8, 9 is not a Pythagorean triplet.
Go.
Let us see one theorem. Similarity and right angle triangle. What is the statement? If triangle is right angle triangle and if altitude is drawn on the hypotenuse, then the triangle is divided in two triangles. Those two triangles are similar to original triangle and similar to each other. So in a right angle triangle, if the altitude drawn on the hypotenuse, then two triangles formed are similar to original triangle and similar to each other. Suppose this is triangle ABC where angle B is 90 degrees, segment BD is perpendicular drawn on the hypotenuse. So here triangle is divided in two triangles. Which are these two triangles? This is triangle ADB. This is triangle BDC. These two triangles are similar to original triangle. This one is original triangle and they are similar to each other. So this is given to prove triangle ADB is similar to triangle ABC. Triangle BDC again similar to triangle ABC, and we have to prove all three triangles are similar to each other. Now consider triangle ADB and triangle ABC. See, triangle ADB and triangle ABC, angle A is common. Angle A is congruent to angle A, common angle. Angle ADB, this is right angle. Congruent angle ABC again right angle. So what we have proved, two angles are congruent to two corresponding angles. Therefore, triangles are similar by AA test of similarity. So thus we have proved first one, triangle ADB is similar to triangle ABC. Now consider the second, BDC and ABC. Angle C is common. In triangle BDC and triangle ABC, angle C is congruent to angle C, common angle. Angle BDC, see angle BDC, right angle. ABC, again right angle. Therefore, angle BDC congruent angle ABC, each 90 degree. What they prove? Two angles are congruent to two corresponding angles. Again, triangle BDC is similar to triangle ABC. What we have proved? ADB is similar to ABC. BDC is also similar to triangle ABC. So, from statement 1, statement 2 and transitivity, what I will get? Triangle ADB is similar to triangle BDC is similar to triangle ABC.